Welcome to today's webinar. Today, we're going to look at how to secure your Automate server on the internal network. And before we get too far, this webinar is being recorded, and we will have time for questions at the end. So feel free to make use of that Q&A box. We do have a mixed crowd today, so we'll start with some background information, but by the end, we're going to cover all the crunchy technical details, and we're going to go ahead and have a live demo. So let's get started. To get some introductions out of the way, I'm Jeremy, the founder of Automation Theory. We're a small consulting firm that specializes in Automate infrastructure. Being smaller, we know our clients fairly well, and we strive to take care of your Automate servers so you can take care of your clients. We also have skin in the Automate security game ourselves. We're using the same technologies to go ahead and protect our own systems. Before we get started today, we do have a promotion going on. Here at Automation Theory, we're celebrating Cybersecurity Awareness Month, and we're doing a social media giveaway. So if you go to our site, there's a slider on the homepage there. You can click that and be able to sign up. We're trying to go ahead and grow our social media following. So anybody who signs up and likes our pages will get put into a drawing, and we're giving away 2 prizes there. First one is a YubiKey 5 NFC, and the other is an Aegis 3 hardware encrypted USB drive. Those YubiKeys are super handy if you're using Duo or as your MFA provider. It's just super slick to be able to hit that little key in your USB port. I am very convinced once you go YubiKey, you never go back. So with that out of the way, let's go ahead and talk about Automate. Before we protect an Automate server, we need to understand where it's vulnerable. Most Automate servers never get a MySQL update after they are stood up. And we found that the average install date is right around 2017 for an Automate server. We let all sorts of tools connect to Automate. The big ones are the reporting suites, your BrightGauge, your Grafana, any other in-house reporting integrations you have. And on top of that, as far as security is concerned, we only scan Automate from the WAN normally. So we never see the inside and or anything that is misconfigured or isn't hardened. And I like to call this alligator hardening. It's very armored on the top, and then there's a soft underbelly underneath. So at this point, we always like to stop and do a little bit of a PSA for people to check their Automate servers. As you can see on the slide here, there's an MSP to this day who has MySQL open to the world. You can see the timestamp there. That screenshot is straight out of Shodan from earlier this week. So make sure that you are properly firewalled, and also make sure to check, make sure that RDP isn't open either. A lot of times that will get opened for migration projects and things like that, just never cleaned up properly. Before this webinar, I actually had a chat with Mr. Kyle Jackson. He is one of the senior program managers over at Connectwise. And they're actually planning to go around and to contact partners who have their MySQL ports open to go ahead and help them get their firewalls configured. And I do want to make mention here that yes, the Connectwise documentation does say that you should go ahead and close that MySQL port. So let's move on and look at some attack patterns. So we want to defend Automate against attacks, and attacks of multiple phases. This slide looks familiar. You're not having deja vu. In our previous webinar on reverse proxies, we had this same cybersecurity intrusion kill chain graphic, and we were looking at the beginning stages of an attack. Today, we're going to be looking at the later stages here. We're making the assumption that an attacker has gone ahead and made his way in and is trying to attack the Automate server. Working backwards from the end, The attacker these days almost always is trying to deploy ransomware. And the fastest and easiest way to do that is straight through the Automate database. And the command and control happened on the initial intrusion point. And depending on the particulars, it's not actually required for the final leg of the attack as long as we can get a MySQL connection open to Automate. So today we're going to look at those intermediate steps of how an attacker on the network would actually gain access to that Automate database. So with that, let's look at the MySQL configuration a little bit more closely. So between the defaults from Oracle, some of the configuration guidance from our friends at Connectwise, and some bad tutorials online, there are a number of common issues that we see frequently with MySQL configurations that can be used in an attack. First up is the bind address on the left there. And in Windows, that defaults to the star wildcard, which means that MySQL is going to listen on every network interface. And the defaults for any Linux MySQL packages, it actually defaults to localhost. So you must explicitly open up that access. Where this really comes into play is for the smaller MSPs out there who have a single all-in-one Automate server where the database is installed right on the app server. Unless you have a reporting integration that is phoning home directly to the database, there's no reason for a single Automate server to be listening on any other network interface besides localhost for MySQL connections. So for those smaller MSPs, that is something we would definitely recommend. Moving along, next up is max connect errors. This is something right out of the Connectwise documentation, and it, by their recommendation, should be set to 10,000. The reason behind that is during the nightly maintenance window, there's some credential rotation that goes on. And so it's quite possible to have a number of authentication failures as that password is rotating, especially if you have a big, busy Automate server. What I like to point out here is that if you compare this to an AD lockout policy, normally, you might give an end user maybe 10 attempts for their password before you go ahead and lock that account out. And at 10,000, this starts to become a candidate for brute force attacks. So we normally recommend lowering it, but we don't have a hard and fast rule here. For smaller Automate servers, you could definitely tune that down quite a bit, especially if you are in that single server boat. The default value is 100. That's a little small for an Automate server. And the important thing to note here is that once you hit max connect errors, if you have 10,000, 5,000, 2,000 authentication failures in a row from the same host, then it basically locks you out. And so if things do go sideways in that overnight maintenance, you will end up breaking your Automate server. So please tune this slowly and carefully. Moving along, we come to secure file priv. And this is bad internet tutorials 101. So if you have this variable set, as you see on the left, with just empty as an empty string, that means that MySQL can import and export files to anywhere on the MySQL server. We'll examine this a little bit closer in some of the upcoming slides, but basically this can be used to inject malicious DLLs through MySQL onto the database server and or your Automate app server if that happens to be open. So you want to definitely define that as a path. It doesn't matter a whole heck of a lot where it is unless you have some automation set up around automated imports to your database. After that, we have local infile, and this controls the importing of files on the server. So it's a little bit different from secure file crib. The idea is with local in file, MySQL could like import a CSV flat file into the database. Where this gets dangerous is that in the Windows world, MySQL is either running as local system or network service, which means any file either of those permission levels can access can all of a sudden be imported into the database. The common attack vector here is for an attacker to load in certain registry hives to go ahead and try and get Windows hashes, Windows credentials, and try and use those to pivot further into your environment. Next up, we have our SSL settings. In MySQL 5.6 and before, TLS is turned off by default, and in 5.7, it is enabled, but there's no cipher hardening. So as we'll see in the following slides, having good encryption on your traffic is very important, especially in a split server environment. And we do recommend enabling that wherever possible. And last but not least, we have log error verbosity. This is the replacement for the log warnings variable, and you'll want to set it to at least 2, if not the default of 3. That way, if there are failures to authenticate against your database, you will capture that in some sort of log and be able to work off of that. So with that, let's start breaking into MySQL. The first step in a MySQL attack is to go ahead and gain credentials. Certain patterns in Automate do lend themselves to brute force attacks, but here we're examining a classic man in the middle that could be done in any split server environment. What you see on the slide here is a traditional ARP spoof. And if MySQL is running in plain text, or if it's vulnerable to SSL stripping or downgrade attacks, we can go ahead and intercept those hashes over the wire, as you can see in that lower pane. We can also intercept some other data as well. So let's take a look at that. There's an architecture item I always like to make note of, and that is that Automate encrypts its credentials at the database layer, not the application layer. As a result, although your data is encrypted in transport to the server and it's encrypted at rest in the database, it can be potentially transmitted plain text between the app server and the database server if you're on an old version of MySQL, or again, if there is a downgrade vulnerability. MySQL 5.7 does default to encrypted connections. It also automatically sets up these certificates for you, turns on TLS, and is much more secure in that regard. But as you can see, we were able to sniff this password in plain text over the wire. So with that, let's go ahead and jump back to those hashes we gathered and keep going with our attack. The next phase after we have that hash is to go ahead and crack it. An attacker can potentially sit on your network and collect and try and crack hashes for really long periods of time. It's also worth noting that these days you can get cloud VPS servers with high performance CPUs for less than $1 an hour with 32 or more cores. So when we think about credential security, we do need to be thinking the long game there. And as you can see in our example slide, we managed to crack this hash in 1 second because it was on the well-known Rocky word list. This was taken on, or this was performed on a MySQL 5.7.35 server. At the time, earlier this week, there were no published vulnerabilities. And as we'll see later in the webinar, MySQL patches actually came out a couple days ago. So there are vulnerabilities now. But this attack is just weak credentials plus lack of encryption. So this is, cybersecurity basics 101. And that's something that we really wanted to bring awareness to being Cybersecurity Awareness Month. So let's go ahead and look at how to actually attack now that we have database credentials. So with the creds, it's just a matter of connecting to the database and running a single insert command. As you can see on the slide there, it takes a fraction of a second, and we hit every computer in Automate. The next time those computers check in, they're going to pull down whatever that command is and run it. It's also worth noting that otherwise, with database access, the attackers can also create accounts for themselves, flag them as integrators, get logged in without MFA, and perform more complex attacks. It's also possible, now that you have database access, to go ahead and cover the tracks. They can delete the history, and otherwise make it very difficult to actually ascertain what happened as you try to investigate, especially because by default, if you have a successful database connection, there's nothing in the MySQL logs about that. So let's go ahead and take a closer look at that encrypted payload. So as you can see on this slide from the Automate web UI, that command was indeed picked up by Automate. That agent ran it, and you can see the technician is our local Cali hostname, and that our payload was delivered and got some extra XML output there too. For anybody who's wondering, that PowerShell command see on the bottom of the slide was encoded, and then that command that we inserted into the database was actually, it wasn't encrypted, it was base64 encoded. So we did that primarily to not fuss around on the command line with escaping that query in the quotes, but it's also a method used by attackers to go ahead and evade detection. So with that, let's see this in action here. We'll flip over to our Cali system. All right. So at this point, we are logged into Cali, and we're on the network. So our first step here is to go ahead and gather some hashes. So we'll go ahead and fire up header cap. Disable sniffing for the moment. And the first thing we'll do is we'll go ahead and scan for hosts. This network is fairly small, and we found 7 hosts, and we can go look at those. So our MySQL server is ending in .25, and then our Automate server is ending in .13. So we are going to add those to the target, and then we're going to start doing some ARP poisoning. We'll go, and we will also start sniffing. So at this point, we are just waiting for application traffic. And in our bottom pane, we will go ahead and see hashes come by as web requests are made to Automate, as the database agent does maintenance, plugin functions trigger, things like that. So let me make sure our attack started. Dangers of live demos here. And at this point, we can also go ahead and try actually do things inside of Automate. See if we start to get some hash data. And we are not, but we actually prepared for this in the event that we didn't get any cooperation. And we do have that hash on file. There we go. Okay, took long enough. And here you can see that this is the ASP Lab Tech 1. This is the process running the IIS web front end. So its hash is there, and then eventually the root user is used by the database agent, and that will come across as well. So we do have that hash on file. Since this is a live webinar, sometimes waiting for that hash can be a lengthy process. So we will go ahead and pop open a terminal here. And we're going to walk through exactly what we saw in the slides. And our first step here is to save this file out to a hash, or this hash out to a file. So we will go ahead, paste that hash. And now we've, previous to this, we have gone ahead and extracted the Rocky word list. It is zipped up to conserve space. So we will paste in this command. We're using the good old John the Ripper on our hash file, specifying the word list and our hash format. And you can see, there we go. In 1 second, we have cracked our hash, and it is P at $word. Somebody thought they were being clever when they were saying this root password for this environment. So we now know that we have the root username and password. So at this point, it's a matter of connecting to the database. We can do that right here on the command line in Kali. So this is the MySQL client. Username is root. The host is our IP address. The -p is going to prompt us for the password, and the -a will prevent it from trying to pull in table autocomplete metadata. So we'll type in our password. And we're connected. And we can just do a quick show databases. And you can see that we have our lab tech database and some other things from our development environment here at Automation Theory. So I will go ahead and take our command, and we will paste this in, one-liner, and we'll hit go. And you can see that less than 1 second, it went ahead and updated. So now back here in the Automate Web UI, you can see that there were no commands, that it successfully executed a command. Again, we have our root at Kali local domain. And down here, this was just a PowerShell script. It pulled over the local network, write the word pwned to the command line. So it did go ahead and pick that up. Of course, it's running as an NT authority system like the Automate agent does. And so that right there is, in a nutshell, how you would go ahead and break into an Automate server on the LAN. And if we go back, I don't know that we have, actually we do have a root hash. So over that couple minutes there, we did manage to actually pick up the root user hash. So that's all there really is if you are running an old version of MySQL or not using encryption. So with that, let's go back to our slide deck, and we can look more closely at how to go ahead and start defending against these types of attacks. The biggest thing you can do to protect MySQL is to ACL the inbound connections to it. We encourage this at the Windows firewall layer and anywhere else in your network where you can go ahead and control network traffic. We'd also like to note, as you can see on the slide there, that Automate doesn't support the option to force encrypted connections to MySQL. So as you're designing your Automate networks, you should assume that there's at least the potential for plain text traffic. Otherwise, like any application, it's important to keep MySQL patched. MySQL patches are released quarterly, and a majority of them contain at least 1 or 2 SSL bug fixes, since MySQL does come bundled with OpenSSL. And as you can see on the slide, patches came out on Wednesday. So I guarantee almost everyone on the call here, if you have an Automate server, you have a MySQL database that needs to be patched. It's also worth noting that you can go ahead and get the CIS guidelines for configuring MySQL. That is a free download right on the website. You can go out and search for that. And it's not only the configuration file items we talked about, but they also have other guidance in there that is highly recommended. The other thing, for larger MSPs who have the security budget, we do recommend MySQL Enterprise specifically for its query firewall feature. It has the ability to go ahead and record MySQL traffic and basically turn that into a whitelist. And then you can turn on the firewalling, and anything that does not match the parameterized pre-recorded queries is blocked. It's rather spendy. And here at Automation Theory, we're doing a little bit of R&D on a plugin that could be used to block injection attacks in a similar way at a much better price point. Otherwise, we're also working on a utility to go ahead and rotate that root password. So just to make it easy for partners to go ahead and make sure that those credentials are indeed up to snuff, that password is encrypted in various parts of the application. So if you just log into your database and change that root password without syncing it up with the application, you will actually break Automate. So let's go ahead and switch gears here and look at other attack vectors on the LAN. So any other integrations you have running in your network that you allow to connect to Automate, either with a database or even API access, can be used against you if they are compromised. Here on the slide, we have an example of Grafana, a very popular reporting suite. And here, there's a quick and dirty table I put together. And you can see we're able to go ahead and dump the usernames, the permissions, the hosts where those accounts are allowed to connect from, and those authentication string hashes. So just like we looked at before, those two, you can take those offline, crack them at your leisure, and once you have cracked the password, they can come back with a vengeance. At the beginning of the year, we published a blog post about the 2021.1 patch user account changes. And in that blog post, we mentioned that it's important to think about permissions when you're creating your database user accounts, just like your API accounts. Does your dashboard user need permissions to do an agent check-in or to retire a computer? Is it ever going to be running patch report calculations or anything like that? Most likely, you need it to access just a handful of tables, and it's going to be very much worthwhile to go ahead and identify what those are and go with a least privilege model rather than over provisioning that user. We also always like to note that even read-only access could be used maliciously. If you think about it, between the computer's password and hotfix tables, an attacker is going to have public IP addresses, credentials, and a list of what those devices are vulnerable to. And with that data, they can launch a secondary attack, even if your internal security layers are enough to stop a direct attack through Automate. Let's go ahead and transition to the operating system layer. So MSPs are super familiar with Windows security on the LAN, and we're not going to dive really deep into those types of attacks here. However, Hardening a server in a sane way is something that can be a little bit tricky for anybody. Here at Automation Theory, we recommend the open source project Hardening Kitty for anyone who wants to harden their Automate servers, especially if you want to harden them beyond the guidance that came out from Connectwise earlier this year. I'd start with that and then move on from there. Hardening Kitty is a PowerShell script, and in a few minutes, you can harden the OS. It has a lot of great options, and we talk about that a little bit more in our companion blog post. Also, don't forget the rest of your security stack in the grand scheme of things when you think about protecting your Automate server at the OS layer. Some of the Kaseya users avoided the ransom because their endpoint software was scanning and caught that malicious payload that the agent was trying to download. Likewise, in preparing for this, as you can see on the slide there, the endpoint in our lab environment blocked an attempt that we were doing to show that a secure file priv issue where you can actually go ahead and inject malicious DLLs and get system level access on the remote server. Our endpoint blocked that. So don't discredit Cybersecurity Basics 101 in the grand scheme of all this. And finally, don't forget about the OS features that come built into Windows, like your UAC or the Windows Firewall. Historically, there have been some Automate server setup tools, and they would go ahead and turn off the UAC and create wide open allow star rules for MySQL and other services running on those systems. So we highly suggest doing an audit of those settings, enabling your UAC, and actually using your Windows Firewall to properly ACL and restrict what can connect to MySQL and IIS on your Automate server. We also want to call out that there are some additional security optimizations coming soon. First off, this month's Automate patch, which is not out as of yet, is going to bring with it support for MySQL 8 and official Server 2019 support. Server 2019 contains some security improvements over the previous flavors of Windows Server, and MySQL 8 is going to bring security fixes until 2026. So for any MSPs out there who are looking to plan out their upgrade projects, if you're running on MySQL 5.7, probably over the next year is probably the best time to upgrade. But if you're running a 5.6 or even 5.5 or any other unsupported flavor of MySQL, we recommend upgrading immediately to something that is supported. And as you might have guessed, that is something we can assist you with. Here at Automation Theory, we offer a variety of services to help MSPs get MySQL patched and hardened. If you're looking for a one and done type service, we offer both MySQL patching and custom config file tuning and review as flat rate services. If you're looking for something for ongoing assistance or keeping your MySQL patched, configured correctly, and optimized, we have our new maintenance plan product, and that's a monthly subscription. It includes all of your quarterly patches, an annual review of your database config with performance benchmarking, plus our plugin database tuner for some optimization. And last but not least, we're also launching a new flat rate server migration service for any partners out there who want to take the opportunity to move Automate to a fresh new environment now that we have Server 2019 support. So with that, anybody have any questions? I see one question came in chat about